Stars are the very lifeblood of our galaxy and of mankind. Scientists are constantly discovering new ones, so it's important to know how they form and where they come from.
This is the life cycle of a star. Stars are born in nebulas, aptly nicknamed stellar nurseries. Nebulas are giant clouds of cosmic dust and hydrogen gas. Gravity slowly pulls the molecules together until they become compressed and start to collapse, causing the core to heat up. The next stage is the protostar. The star's core is heating, but is not yet hot enough for nuclear fusion to occur. The protostar is surrounded by cosmic dust. As the cloud collapses, it begins to spin into a protostellar disk, which generates wind to blow away the dust. The main sequence of a star comes next. At extremely high temperatures, hydrogen atoms begin to fuse to form helium atoms. Nuclear fusion happens in the star's core, releasing an immense amount of energy and outward force to counteract the inward pull of gravity. This stabilizes the star and ushers it into its longest lasting period. Our sun is in the main sequence stage right now, and the nuclear fusion happening in its core is what allows us to enjoy light and heat here on Earth. Red giants are important because their luminosity serves as landmarks so that telescopes can measure distances between galaxies. Red giants occur when a star has run out of hydrogen fuel for fusion and begins to die. The equilibrium between gravity and fusion pressure is lost, and the core of the star begins to collapse into what is known as a white dwarf. The star leaves behind a hot shell, which eventually cools to form a black dwarf, the official death of the star. The last stage of a particularly large or heavy star is called a supernova. After hydrogen fusion ends in the core of the star, gravity quickly takes over. In seconds, the star collapses. The explosion is the largest our universe has or will ever see. A dense core is left behind, along with an expanding cloud of hot gas, which undergoes nucleosynthesis, a process that creates heavier elements such as carbon and uranium that then shoot off into the universe. What remains after the explosion of a supernova is a black hole. Black holes occur when large amounts of matter are compressed into very small spaces. The resulting gravitational field is so strong that nothing, not even light, the fastest thing in our universe, can escape its grasp. It eats everything from pizza to ice cream to entire planets. Black holes' curve our very understanding of physics and space-time, making them important for scientists and astronomers to research.
So, whether you live in New York City where you can see just a twinkle, or in a rural area where there are constellations all around you, it's important to always look